Okay, I am going to go over the first page of the isotopes worksheet. And as we go through this, I will be switching back and forth to the periodic table. So here are three isotopes of the element. The element is carbon. The number 6 refers to, that is the atomic number. You could also say it's the number of protons. Or you could also say it's the number of electrons in a neutral atom. I apologize, my writing today is much worse than others. What does the 12, 13, and 14 refer to? 12, 13, and 14. That is the atomic mass, or it is protons plus neutrons. How many protons and neutrons in the first isotope? That would be 12. How many protons and neutrons in the second isotope? That would be 13. How many protons and neutrons in the third isotope? That would be 14. So uranium-235, 92 is the atomic number, 235 is the mass. So the atomic number of uranium-235 is 92, and the atomic mass is 235. The number of protons is going to be 92. I'm going to go with a thicker one and see if that makes my writing any better. So if it has 92 protons in a neutral atom, it should have 92 electrons in a neutral atom for both of them. And how many neutrons? Well, this is the mass. So the mass is protons plus neutrons, and that's the protons. So if we take 235 minus 92, that should give us 143 for that one. And if it's 238 minus 92, that should give us 146. That's a 6. 146. Boron 10 and boron 11. Its atomic number is 5. Its atomic mass is 10 and 11. The number of protons is 5. Its atomic number is 5. So the number of electrons in a neutral atom, if it has 5 protons, it needs to have 5 electrons. And if it has an atomic mass of 10, that mass is protons plus neutrons. So 10 protons plus neutrons minus 5 protons should give us 5 neutrons. And boron 11 has a mass of 11 protons plus neutron minus 5 protons should give us 6 neutrons. The next one is a little bit harder, but what it does is it kind of lets us take a look at how they come up with the atomic mass as an average. And it says naturally occurring europium consists of 2 isotopes. Of 2 isotopes was a mass of, that doesn't make sense, a mass of 151 and 153. If europium-151 has an abundance of 48.03 and europium-153 has an abundance of 51.97, what is the atomic mass of europium? Okay, so of the 151, 48.03%, and we're going to turn that percent into a decimal because that's what a percent is, 0.4803, and we have 51.97 of the 153. So if we take on our calculator, take 151 times 0.4803, we get 72.53. And I rounded there. And if we take 153 times 0.5197, we get 79.51, and I rounded there. And if we add them up, so that will give us 100%. So if we take 72.53 plus 79.51, we get 150, oh, my fives are really bad today, 152.04. So that is what would show up on the periodic table. So that's how that's calculated. And okay, so helium is He. The atomic number of helium is 2. The number of electrons is 2. The number of neutrons is 2. The mass is going to be 4, because that is going to be the atomic number plus the number of neutrons. Isotopic notation is going to be He-4, and in the directions I kind of had them be the same. Ti is titanium, and I'm just going to double check that. Ti. There it is. And its atomic number is going to be 22, because it has 22 electrons. Number of neutrons that it's going to have, well, if it has a mass of 50, and if it has 22 protons, that should tell us that it has 38 neutrons. And its isotope notation is going to be the same. These are going to be the same, Ti-50. Atomic number of 73. Well, the atomic number of 73 is, I'm having a tough time reading it on my black and white copy. So I'm going to go to here. Tantalum. So 73 is tantalum, and its symbol is Ta. Its atomic number is 73. It'll have 73 electrons. It has 108 neutrons, so its mass is going to be 108 plus 108 neutrons plus 73 protons, 181. So its mass number is going to be 181, and it is going to be Ta 181. Gallium is Ga, and its atomic number is 31, because it has 31 electrons. It has 39 neutrons. It's going to have a mass of 39 plus 31, should give us 70. So it has an atomic mass of 70, or a mass number of 70, and it is going to be Ga 70. And this one here is telling us that it's carbon. and its symbol is C, and the atomic number is going to be 6, and the number of electrons it has is 6. Well, if its mass is 13, so if its mass is 13, and of that 13, 6 of them are protons, then 7 of them must be neutrons. And once again, I'm having you do this differently because you're typing. Next, we have Ra, which is radon, I do believe. Radium. And its atomic number is 88. So that tells us it has 88 protons. So it's going to have 88 electrons in a neutral atom. And it tells us its mass is 226. So if it has 226 neutrons plus protons, and we have 88 protons, that should give us 138 neutrons. 8 plus 8 is 16, 3, 2, okay. And then the last one tells us that it has an atomic number of 83. So if we find 83, that's bismuth. About the only time you'll ever run into bismuth is if you are a hunter. You may buy shells that are made out of bismuth. Its atomic number is 83. It has 83 electrons. It has 127 neutrons. So if we have 127 neutrons plus 83 protons, so that gives us 0. We're going to add the 1, 1, 1, 2. That gives us a mass of 210, and that will be Bi 210. And I think that's it for that page. That is. Have yourself a great day.